All right, in the set portion of our Unit 4, Lesson 3, Ready, Set, Go, we are working on what we did in class, which is either solving equations or solving a literal equation. And so just the difference quickly between the two of them, when you solve an equation, you end up getting a value. So I might get like x equals a number, or I could solve for a different variable. I might get y equals a number, or t equals a number. But when we solve a literal equation, and when I was your age, sometimes even now, I think that vocabulary of like, why do we call this a literal equation? That always was confusing to me. But solving a literal equation typically means that we are going to have multiple variables in our equation, and that what we can do is, I think of it as we're just going to isolate the variable we're solving for, and we're going to express that variable in terms of the other variables and numbers. So in terms of other variables and numbers in the equation. Okay, so in number 3, if we solve for m, if I notice there's also a y in my equation, so this is a literal equation. How about this? I'll do all the literal equations in purple so that we can, and I'll do the other ones in a different color so they'll stand out to us. So if I solve this for m, that just means I want to isolate m. So I want to start by undoing what's been done to m. So remember, we want to work backwards when we're solving. So if I think of GERMDAS, grouping, exponents and radicals, multiplication and division, addition and subtraction, you can still call that PEMDAS if you really want to. When I solve, I'm working backwards through the order. So I look for any addition or subtraction to undo first. Since I have addition of 6, I undo it with its inverse operation. So now my left-hand side is y minus 6. And on the right, I have undone the addition of 6 to 7m. So I have 7m by itself. And then my last step is I would solve both sides for m. So I would have to divide by 7 to undo that multiplication. And we get y minus 6 divided by 7 equals m. And there's a few other ways you could express that equation, but that's how I would personally prefer to leave it. Okay, number 7, I notice that we're solving for x, but there's no other variable than x. So we are just solving an equation. And so I'll work out the equation in green because, I just picked green. So, all right, again, our goal is to undo what's being done to x in the opposite order. So if I look at my equation, I don't have grouping, but I can see that x is first being multiplied by 2, then divided by 5. I suppose you could think of that as just x being multiplied by 2/5. Then we're subtracting 9 to get 6. So as I work backwards, I want to undo the subtraction of 9 first using the inverse operation, which is to add. So on the left-hand side, when I add 9 to where I had subtracted 9, those operations undo each other. We could think about algebra as a process of doing and undoing. And then on the right-hand side, I can add 6 plus 9. I just get 15. And just to pause for a second over here, just to clarify, you cannot subtract 6 from y because those are not like terms. You could subtract 6y from y, but not the constant 6 from the variable term y. Okay, so going back to our problem in number 7, if I'm trying to, again, get x by itself, we could do this in 1 or 2 steps, but I am prone to next get rid of that division by 5. So I might multiply both sides by 5. So I now have 2x isolated on the left, and then 15 times 5 is, 50 plus 25, 75. All right, and then our last step would be to divide both sides by 2. So if I divide both sides by 2, I get x is 75 halves, which is like 30 something and some change, getting really close to 40. And so that does seem kind of like a little bit of a big number, but if we were to plug it back in, the nice thing about solving an equation, unlike a literal equation, is you could check your work with these, and we practiced that in class too. And although it's not required for this practice, I think it's empowering because like on a test, for example, you could check your work. So we would check our work. We said our solution we got was x equals 75 halves, or you could write that as a decimal. We could check our work by substituting that back, that solution back into the original equation for x, and every time we see x. All right, so if I do that, I plugged that 75 halves in for x. Well, multiplying that by 2 just makes 75. So now I have 75 divided by 5 minus 9 equals 6. And then if I think how many times does 5 go into 75? Well, we could just divide, right? 5 goes into 7 once, and we'd have a remainder of 2. We think of that as really being a 2 and then a 2 in the tens place, and then a 5 in the 1, so a 25. We're going to get 5 more 5s in there. And 15 minus 9 is 6. And if you're following along at home, you can, of course, use a calculator if you prefer. So our solution is correct. I'm not going to do that for all of them. All right, much like the practice, I noticed that 4 and 8 look kind of similar to 3 and 7. I guess maybe if I'd been going in order, I would have done 3 and then 4. I wasn't really paying attention there. My brain wants to go from left to right, not top to bottom. So in number 4, we're solving for m, and we'd already solved for m above. I just have more variables. So you might recognize y equals mx plus b as our slope-intercept form of a line. I hope you recognize it by now. And if I'm solving for m, I'm still going to do the same steps as I did above. I just have a b where there was a 6 and an x where there was a 7. So I'm going to undo the addition first rather. So I'm going to subtract b from both sides. And on the left, that's just y minus b. And on the right, I've undone the addition of b. So I'm left with mx. All right, then my last step, I want to isolate m, and x are being multiplied. So in order to unmultiply, I want to divide. Those are inverses, inverse operations. So I get m equals y minus b divided by x. Okay, well, I know I'm not going in order, but since we already did number 7 and number 8 looks a lot like it, it might make sense to do that one next. No, they look very similar, except I have a 9y in number 8 where I just had a 9. But as we talked about in class, the steps for solving literal equations are the same as the steps for the equation. The difference is I won't get a value. So 75 over 2, that's a value, that's a number. I'll get an expression when I do this. Okay, so as before, instead of adding 9 to both sides, we could add 9y. Because again, we want to undo subtraction before division or multiplication. By adding, oops, I don't know, I wrote 25 there. By adding 9y to both sides, those have undone each other. On the right-hand side, though, I have 6 plus 9y. Ooh, we got to be careful here. So now, if I want to undo the division of 5, I will do so with multiplication. But when I do that on the right-hand side, because I have 2 terms, I must put them in parentheses. And I could choose to either distribute or leave it as it's written. But it would be incorrect to only multiply one of those numbers by 5. We must multiply both by 5. All right, and then in our last step, so right now, let me rewrite this, it's a little muddy. We have 2x equals, I don't care if you distribute or not, but I'm going to distribute just to clean it up a little. So 5 times 6 is 30, 5 times 9 is 45. So 5 times 9y is 45y. In our very last step, we want to divide everything by 2. So when we divide both sides of the equation by 2, I'm dividing everything on that right-hand side by 2. Okay, I'm going to just do one more pair for the video. I think 5 and 6 are pretty straightforward. I think we should look at 9 and 10. So you have a few options here. You could, in both of these, distribute the 3/4 to eliminate our grouping. Some students really wanted to write that as a decimal distribute. You could do that too. 0.75 and 3/4 are the same number. To me, I think the easiest thing to do here personally is to get rid of the fraction. So if you think 3/4 times something is 12, the something is just that x minus 2. So I could think of this as two factors that have a product of 12. So I could divide both sides by 3/4. And remember that when you divide by a fraction, like dividing by 3/4, that's the same as multiplying by its reciprocal 4/3. And you could do that all in one step. But I will tell you, my brain, and I'm pretty good with fractions, I often prefer to do it in 2 steps, because if I just multiply everything by 4 first, I get rid of the fraction. So that's how I'm going to do it. You could try it whichever of those ways you prefer. And as long as we get the same answer, we'll be good. So on the left, I'm going to multiply by 4. Because 3/4 times x minus 2 is multiplication, I'm not like distributing this or anything. Just the 4 times 3/4 gives me the whole number 3. And that's why I wanted to multiply by 4. On the right-hand side, I'll just do 12 times 4, which is, wow, I almost said 24. That is 48. So 12 times 2 times 2. All right, but on the left, I still have that 3. So now you could distribute the 3. There's nothing wrong with that. But again, if I tell you 3 times something is 48, we know what that something is. We know by using division. So what I might do here is divide both sides by 3. If you prefer to distribute, that's okay. There's nothing wrong with that. We should get the same thing. All right, so 48 divided by 3, I think that's 16, but I'm really bad at doing math in my head, so let's see. 16 times 3 would be 30 plus 18 it is. Okay. And then lastly, to get x by itself, we could add 2 to both sides and get x equals 18 there. All right. So similarly, I don't know, I did that one in orange. That was a regular equation. Similarly, we're going to try the literal equation beneath it. We could, again, do this in the same steps, or you could try like doing it a different way. But honestly, the steps don't change. We just have to be mindful of the variable y. So I'm going to try it in the same way. I'm going to multiply by 4 on both sides of my equation. So that leaves me with 3 times x minus 2y equals 48. Then, again, if you wish to distribute the 3, to me that makes the process longer. I like to do less math, believe it or not. So I'm going to divide both sides by 3 to get x minus 2y equals 16. Because once we divide by 3, we can drop our parentheses. And then lastly, to isolate x, I'm just going to add 2y to both sides. So x equals 16 plus 2y. All right, so that's it for the set part of the homework.